Do I have to present myself? Okay. Well, here's my speech. I'm Tanja Fell. I've worked for Fraunhofer IVV for 10 years, and I've worked in polymer recycling for 10 years. I originally studied process engineering, and I'm happy to be able to tell you a bit about recycling for the next 20-30 minutes, about recycling in connection with cosmetics packaging. I'll talk a little bit about the Fraunhofer-Institut first. I'm not sure to what extent you're all familiar with it, whether you know what we do, so I'd like to present our institute, the recycling department I'm working in, and our activities in polymer recycling and cosmetics. So this is an image. We have 75 institutes in Germany by now. I'm in Freising, in the Freising location, so we're pretty close to Munich. It's just about 30 kilometers, so I didn't have to travel far to get here. We're also very close to the headquarters of Fraunhofer, which is in Munich. And we are dealing with applied research. We have 2.8 trillion euros in total. And it's only 30% of contract research, and 70% is generated by public research. So we're localized in Freising and Dresden, which is our sister institute. Dr. Andrea Büttner and Professor Dr. Jens-Peter Maischak are heads of our institute. He is head of the institute in Dresden, and she is heading the Freising Institute. We have a budget of 30.4 million euros, and you can see that the large part of that is gained via external contracts and a short share of public funding. The two locations combined have 325 employees, among whom there are 184 scholars and graduates. So how do we collaborate with industry? So on the one hand, we work together with the industry and publicly funded projects through joint research applications, although the industry does its share in the form of funding. Publicly funded projects are usually published, so the results are publicized. And we also have bilateral projects directly with the industry, so you cooperate directly with Fraunhofer-Institut. The advantage of that is that the project results are not published, so they remain between the research and the industry in question. So we carry out joint projects with the industry. So what do we do in Freising and Dresden? Our main area of activity is food, in the food area. So we're looking at high quality, at the promotion of healthy products and ingredients. Another large field is packaging. So to make sure they're safe and consumer-friendly and recyclable, of course. Then there's the whole thing about the processes, how the processes are interconnected, whether the production and cleaning processes are optimized, and find digital solutions for the industry. Then we have product performance or product perception, which is a holistic way of optimizing raw materials and market-ready products. The last area, which closes the loop to packaging, is recycling and environment. And that is where I work in development and recycling environment. So we generate innovative recycling processes. We look at bio-based additives. So what exactly do we do at recycling? We recycle plastics and plastic metal composites. We evaluate plastic recycling plants and processes, and we develop, as I was just saying, sustainable products and additives. And of course, we also carry out the environmental analysis. I quickly summarized the options that you have in recycling technologies and reuse. So you can see the intact polymer chain at the top. So the difference between recycling technologies is, on the one hand, incineration, which is what we want to avoid. This can restore energy, and there are two methods. One is chemical recycling, so which is where you break up this long chain, which was painstakingly created, and break it down and decompose it. So the advantage is that you have the quality of a new product, because this is broken down into monomers, so it can be cleaned very effectively. And the opposite of that is material recycling. So this can be done mechanically, thermomechanically, using various sorting techniques and confounding, and recombine it into a polymer chain. Or there's another approach, and even though it contains the word solvent, it's solvent-based, it is actually also a material process. I'll get back into that later. So the difference between chemical and material recycling is what I just said. In material recycling, the polymer chain remains intact, and in chemical recycling, it's broken down into monomers. So much for the preliminaries. In the recycling business field at the IVV, we deal both with polymers and polymer metal composites. So we develop and license solvent-based processes. This is our CreaSolve process. Some of you may have heard of it already. And we focus the recycling on the target plastics of waste mixtures and plastic composites. So what we focus on is the reduction of contaminants and odors. Moreover, we carry out process development and engineering up to a commercial scale. Something else that we do is technical and economic evaluation of these processes, and we're trying to bring it to market together with the industry. By now, there are 3 working groups within this department. Back when I started, there were just 6 of us 10 years ago. Now there's 30 of us. So, of course, due to inquiries, we've really grown, and the field of research has grown too. So I'm group head of the process development packaging recycling. So I'm looking into the recycling of multi-layer packagings within the CreaSolve process, but we also develop, or rather, we develop further the thermomechanical recycling processes. So we're not just using the CreaSolve process as such, but we also work out techniques for delamination and extraction. Then there is another group focusing more on technical plastics, and they are looking to extract additives out of the processes. So construction waste would be one example. In the past, there were additives used that are by now prohibited, and we can use our technology to sequester those. Another group is us not just working in the lab, but we're also industrializing our processes. So we're supporting the industry and accompanying this process to the point where it's industry ready and the industry can take over management. So let's talk about today's topic, which is probably why you're here in the first place: recycling for cosmetic packaging. As an example, I just brought this diagram. This is best practice. This is PET bottles. So we're handling this pretty well. So for PET bottles, there are collection systems. You all know that. You return your bottles to the supermarket, and then they are cleaned, and this is introduced in a separate cycle, and they can then be reprocessed into new bottles. So this circulation, this cycle, makes sure there are very few contaminants, and it makes it possible that you get an EFSA or FDA petition. So, where do these PET bottles end up? Only 32%, unfortunately, are used to produce new PET bottles. 30% end up in foil or tray production, and 20% end up in the fiber industry. Why do I say unfortunately? Well, actually, it is a pretty good waste stream, and it would be very suitable to close that gap, PET bottle to PET bottle. That would actually be the way to go. Okay, let's get to what I brought you. One of our projects, which we've carried out currently or in the past, so is PCR material, post-consumer recycled, whether we can use this in cosmetics products. So the demand is actually always there. We need packaging that, well, does not damage the environment, and ideally they should be food safe. And so we were asking ourselves, what can we do to remarket these? Dr. Frank Weller, my colleague, you may have heard of him, worked together with Werner and Merz and Beiersdorf to work out a cosmetic packaging guidance, which is a public document. You just need to check the internet and can review the study. So I'll get into more detail on the next slide. But the goal or the benefit was to use this guideline to make it possible to get back to the right way of application. So this is a short, well, not so short overview. And this is the process, an overview of the process. So I said earlier, it is important where this waste appears. This is classified in industry waste, so post-industrial material, and there's class 2, which is post-consumer material, which is in a clear loop, like the PET bottle, for instance. Then we have class 3, which is post-consumer material from mixed plastics collections. So just imagine the yellow bag or the yellow bin, or if you're not from Europe, all packaging waste just bunched together in one big bin. And class 4, that's material which is introduced or is generated via chemical recycling. So then you have all the possible recycling processes. You have thermomechanical recycling with its various steps. Through all these various packagings, there's a variety of contaminants that may be there. I'll get back to that later to explain the difference a bit in a bit more detail. The fact is that from these materials that I've just mentioned, no food compliance can be generated. So Mr. Weller got together with industry partners to figure out how to get to a cosmetics guideline. Mr. Weller is usually asked whether he can rate and assess these recyclates, and then he'll play through scenarios which will get him to a conclusion about the safety of the product. Any questions on that should be directed to my colleague Dr. Weller directly. You can contact him directly, or if you have any further questions or inquiries, he is the person to contact. One example together that which we worked out together with Beiersdorf is this experiment. They wanted a packaging that's recyclable. So We did that on a smaller scale together with a partner, Plaido, and they build these machines. So Beiersdorf provided the collection of this waste that was class 2, so post-consumer waste, which was collected within a system back in their plant, and that's how we were able to produce new bottles after recycling, as you can see here. So how would we do that?
As I just told you, grade 2 means that you introduced your internal return system, like it was the case with the PET bottles here in Germany, which need to be shredded, obviously. They're washed. Normally, you need to do a pre-wash because product residue may well remain in the bottle. And you want to save as much water as possible, so you'd use dry cleaning processes, followed by friction washing. The purpose of that is to remove all labels and all glue residue and improve any odors that may have developed. Normally you use some sodium-based detergent, which you would normally also do for PET bottle recycling processes. So after completing the washing process, you can also recover polyolefins. You can separate that off PET because polyolefins will float on the surface and PET will trickle down. So you can do that kind of separation too. In order to separate water and polymer, you'll run it through a hydrocyclone before you dry it, and you'll run it through a zigzag air sifter in order to remove any labels. And we use NIR to do some additional sorting, for example, if you want to separate PP as well, for example. Another option possible is color separation using IR technology and camera systems, followed by a metal detection process, which is strongly recommended in order to protect your extrusion facility, which is the last step. After sorting and cleaning all the materials, you do compounding with melting filters, and to eliminate other odors, you would use a degassing zone. After completing this process, as we saw earlier, you will end up with a high product quality recyclate, which you can then return into the material circle. So what's the difference to post-consumer waste? As you can see here, that's what post-consumer waste looks like, and it looks pretty clean in that picture. Actually, it's pretty dirty, all kinds of different materials mixed together, different colors. You can see that very well in the lower picture, different kinds of polymers. So everything we may erroneously drop into our collection bins, actually. So we need totally different techniques in order to sort that. So after collecting all those recyclables, how can we actually extract our recyclates? Here in Europe, it's a take-and-bring system, which means the consumers will actually collect all their waste materials and will either drop it into the yellow bin, the yellow bag, and there are also recycling sites. It depends on where you live, in which region or community. It depends on how they want to do it. You would either have to drop it off, or it will be collected from your home and will then actually be passed on to a sorting facility. Once arrived at the facility, they will open up the yellow bags. Next, it will be classified larger than A4 size or smaller than A4 size. Larger films will be automatically separated and removed from the rest using the size classification system, will then be cleaned, will then be put in the film fraction site. That's the 310 fraction, for those of you who are familiar with the principle. Then it will be fed back to the loop And we'll run through the classification process again, followed by a windsifting step, which will help remove smaller films from rigid materials or other packaging materials. As you can see, it's like a mixed layer fraction here. Mixed plastic films that can either be used as such, or you could also use NIR technology to do additional sorting. Next, you remove LPBs, which will run through a magnetic conveyor. And here we have the first NIR scanner, where we would extract different polymers like PET, PS, PP, PE, and all other fractions that have not been recognized during the previous steps of the process. So this is the output after sorting. So you can probably well imagine that seeing as we have more and more plastic weights, we need a lot of sorting capacity, a lot high sorting speed, so the conveyor belts are completely full. And you have to separate it very well, spread it out across the belt in order to allow for the NIR scanner to really recognize individual components on the conveyor belt. Because if the NIR unit recognizes PE, for example, an airstream will be applied to actually shoot it off to the place where it's supposed to go. Right after our sorting unit, we have a fraction that we can actually work with. As I told you earlier, we'll do shredding, washing. Washing means we just draw it through water, and then you can nicely separate it by materials that swim and those that sink down to the bottom. You can also do additional sorting and end up with some granule of the grade for construction purposes, etc., but mostly not for packaging purposes. So what is the difference between a thermomechanical and a solvent-based recycling process? The difference is the following. We have a waste stream coming in, and here we would only use mixed waste because it wouldn't make sense to separate by fractions for this particular process. The next step will be dissolution. So let's assume we're talking about PE, C polymer. We want pure PE recycled as a result of the process. We have selective dissolution agents that can separate off PE. We can also separate PE from PP by means of that process. We have dissolved solutions, which means our cleaning capacity is significantly increased. We have better filtration options here. And after purification, that can be a multi-stage process depending on the requirements, we'll end up with residues, which will then be fed into other processing facilities. And at the end, the polymer that we recovered, in that case PE, we have to remove the solvent. And we do what we call a solvent reconditioning process in order to feed the solvent back into the loop. And at the end, our result is a pure polymer. This is suitable for all kinds of thermoplastic materials. I told you that we apply specific safe solvents, so we can actually remove all contaminants. So we have a very pure granule at the very end. So which is pretty close to virgin material. So what else can we do? What is sort of the starting situation at our institute? First of all, what we do is we look at the waste stream in our lab. We have 100 liters approximately. That's the scale we use in order to develop purification techniques, and 100 milliliters to 1 liter is the scale we'd use first before we transfer that to a technical scale, which is a small scale facility where we can run 100 liters, where we can process approximately 5 to 10 kilos a day. We now have a demonstration facility at demonstration scale where we can actually produce 100 to 1,000 kilos And this unit allows us to derive valid data for commercial scale production and for mass and energy balances. So we've now reached industrial scale, but it's just a demonstration project. We have one unit in Indonesia, TRL8. It's a Unilever unit. So this unit has daily production, and we have a unit in the Netherlands, in Europe, in Terneuzen, where we do polystyrene recycling. We successfully built up that unit, and this is currently about to pick up real production. So our purpose here was to use construction material to actually turn it and recover insulation materials. The Unilever unit wants to separate and recycle mixed waste to recover film that can then be used in the packaging industry. So, what is the capacity of this process? Let me explain about the cleaning performance. PLA, polylactide. The starting material is a waste stream, then included paper, dirt, and PLA. So we tested the purification, the cleaning performance we needed. For those of you who are familiar with that, we run a challenge test. I don't know if you know that, but you expose this material to a certain substance listed here, toluene, chlorobenzene, methyl salicylate, etc. And we would actually check the process cascade to check cleaning performance. And you can see a comparison of PLA versus normal thermomechanical recycling. As you can see, our performance was very good, below the threshold. So here, for example, we have to actually do further calculations to see whether those substances could possibly interfere with the field of application intended. But there is a significant difference compared to thermomechanical recycling, where cleaning performance was not as good. These kinds of challenge tests are also run for PET, for example, in order to assess the cleaning performance within the recycling process. So what other projects did we run in the past? Multicycle is another project example. This was about the recycling of multi-layer packages. This was fibers in the automotive industry. Our result was that project ended this May. So our grades for PE, PP, PA, and PET was of significantly high quality. So we have a unit located here in Bavaria, in Germany. And we had great PP and PA composites from automotive. The recyclates that we produced during that project, the Amcor company, that was our partner in that project. It was an EU project. They produced new films and they built demonstrators in order to illustrate how the recyclate can be used in a composite material and what properties the material can have when using recyclate. I think that is a perfect illustration of a product that can be produced from a recyclate, that's the film used for a new product. And the RPE share was somewhere in the middle here. Here we had EVH, and here we had PP plus recyclate. And here another product. This was also a demonstration product where we tried to use the film or to use the recyclate to produce sachets. We use PP, metallized OPP. And no, we didn't test whether or not this is a product that we could reintroduce into the market, because this was not the aim of the project. The aim of the project was what is feasible, what can we actually do. And of course, we would want to try to reintroduce that into the loop, so that will be the next stages of that project. We have the circular food pack project, for example, where we try to achieve a great stream of materials. So we try to collect food packages and actually recycle them and produce food packaging from that recyclate. Let me summarize the benefits of the Creasolve process. This is the solvent-based process. We don't need high sorting rates. We are selective with regard to the rest of the waste materials. If you want PE, we won't have any other plastic materials mixed in. So the cleaning performance is excellent. We can also actually purify dyes, additives, contaminants, and remove that from the material. With the color as well, it depends, of course. If we only have black packagings, we don't get transparent recyclant out of that, obviously. But we can dissolve blends and composite materials. The molecules remain intact. I explained that to you at the very beginning. So this type of material recycling allows us to add our quotas, which means we have a large stream of mixed waste, which is hard to reintroduce into the loop in the first place. So this technology allows us to provide significant value added, and at the end we'll end up with a very high quality of our recycled polymers. So it's possible to close that loop and achieve circularity. For 3 years now, we have cooperated with other Fraunhofer partners. So we cooperate in fields including material, system, and business. Our goal of that cooperation is to develop new plastic materials that are not oil-based, to make them recyclable and to make them biodegradable. So we work on new elastomers as well. And we want to achieve design for recycling for various product groups. So we're currently developing new recycling technologies to offer alternative solutions. IVV, our institute, is involved in that recycling efforts. So we work with ICT, Institut, in order to do research on chemical recycling, thermomechanical recycling, and solvent-based recycling processes. And we also take a closer look at mixed waste streams, because we want to cleverly combine all technologies in order to seize all opportunities and also make it economically feasible to use all those technologies. So we do not only do recycling technologies, what other services do we offer for the cosmetics industry? So we work on product perception, product optimization, packaging, and hygiene and production. Is my colleague here? Ms. Springer, where's she? We're there. So if you have questions about that, please feel free to approach my colleague, Mrs. Springer, about that. So she will be happy to take your questions. So what services do we offer in the packaging sector? We develop new packaging systems that can be recycled. We try to use bio-based resources. And we actually want to achieve conformity of our packagings, or test conformity of the packagings. Mr. Welle, my colleague, is responsible for that sector. We offer workshops for companies, internal workshops regarding recyclability, use of recyclates, recyclability analysis. And we try to use post-consumer recyclates in new packaging concepts. I would like to thank you very much for your attention, and if you have any questions, please feel free to